Alright, ladies and gentlemen, so we are going to be diving into 5.4, which is all about an extremely important theorem of calculus, kind of probably seen by its name, known as the fundamental theorem of calculus. So what we're going to look into today is the first part of the theorem. So now the theorem we're going to break up into two specific parts. And we're going to be specifically looking at the first part of the theorem itself. And we're going to use it a little bit in application as well too. So the goals for this video and the goals as we dive into this section are to identify the fundamental theorem of calculus. That part will be obviously parts 1 and 2. And then we're going to use it as a way to apply it to evaluate integrals and actually find derivatives of integrals when it's all said and done. So let's take a look here first and foremost. What is the fundamental theorem of calculus, quote unquote, part 1? So let's say, for instance, we have a function f, all right, and that function is continuous as it has been since we've been talking about integrals and cells. That function is continuous on a to b, an interval from a to b. Then what we can say is that then the function f of x, so our antiderivative, capital F of x, our antiderivative, is equal to the integral from a to x of f of t dt, okay? So if f is continuous on the interval from a to b, then the function antiderivative f, big capital F, is equal to the integral from a to x of f of t dt. Alright, this function here will now have a derivative at every single point for a value of x across the interval a, b. So they can be differentiated at every single value of x. Should have no problems taking the derivative at any of the values of x from a to b. And the finisher of this part, alright, is the fact that the derivative of the antiderivative is equal to the derivative with respect to x of our integral function a to x of what we've been saying, f of t dt. Alright, and there's one last little part. So let's think about this before we continue to go on. The derivative of the antiderivative is equal to the derivative with respect to x of the integral of f of t. Well, think about what this is actually meaning here. This is showing us that basically we are going to just be finding f of x. So that is what this is. That derivative of the antiderivative is going to be f when it's all said and done. Alright, so let's take a look here at a couple ways we can actually apply this into some real life circumstances here. So not really real life circumstances, just some examples I should say in general. So let's say we want to apply this theorem here. Let me get a little space going on. Alright, so let's say, for instance, that we are dealing with a, let's see here. Let's say we just want to find, the following integrals. d dx of the integral from negative pi to x of cosine t dt, and we want to find the dx of the integral from 0 to x of 1 over 1 plus t squared dt. Alright, so we're going to use the fundamental theorem of calculus here to go ahead and find the following. So let's take a look here. So our fundamental theorem of calculus. We're going to be basically using what we know about derivatives and antiderivatives as a way to evaluate the following. So let's kind of think here for a sec. If I wanted to find d dx of negative pi 2x of cosine of t. Alright, well, according to our fundamental theorem of calculus, the derivative is supposed to be, alright, the derivative of the integral of f of t should just be f of x, right? So it should just be f of x if we are going from a value of a to, switch to pen, if we are going from a value a to x, alright, our derivative of the integral f of t should just be cosine of x. Okay? All we do is replace it in there. It's just basically showing what the definition of the fundamental theorem of calculus is telling us. Well, same thing goes from 0 to x. 0 in this case is that value of a. We are going from 0 to a value of x. Alright, so the derivative of the integral for 1 over 1 plus t squared should just end up being 1 over 1 plus x squared. Okay? So we're not really trying to reinvent the wheel with that problem. We're just trying to show what the actual fundamental theorem of calculus is telling us inside its definition, or inside the theorem itself. Okay? So from a value to x, that derivative of function f of t, we're just going to be replacing t and x. It's also really is showing us there, because it's differentiable all the way through from a to b. Alright? So that's going to wrap up this very basic, simple video. In the next video, we're going to dive a little bit deeper into another example of using the fundamental theorem and start diving some things into chain rule a little bit more so.